Hello students, today we will discuss halogenation of benzene, that is an electrophilic aromatic substitution. In the halogenation, free halogens can attack only on activated nucleus such as phenol, that is without a catalyst, because here hydroxyl group, phenolic hydroxyl group can activate the benzene nucleus. And if we see the addition of halogens, chlorine or bromine, to benzene nucleus proceed by a radical pathway. So this is a photochemical reaction and addition takes place, or by the addition of peroxides. And halogens are unable to substitute benzene nucleus without a catalyst. So today we will discuss by using a catalyst. So aromatic ring can be substituted by halogens, and it requires catalyst, for example, iron third bromide or aluminium chloride. So substitution of halogens takes place onto the benzene nucleus in presence of a catalyst. So first step is the generation of electrophiles. How the electrophiles can be generated? So FeBr3, it acts as a Lewis acid, and this bromine molecule, it is a Lewis base, and this catalyst, it approaches to the bromine molecule and it polarizes. The catalyst polarizes the bromine-bromine bond, and one bromine atom becomes highly positive and one bromine atom becomes negative. The central atom iron has empty d orbitals to accommodate the electron pairs from the Lewis bases. And generation of more electrophile occurs. So it forms a complex with the bromine, and a complex is formed and it produces the strong electrophile, that is the strong electrophile here. Now, the second step is the formation of carbocation intermediate. The electrophile, that is the bromonium cation, it reacts with a nucleophilic benzene ring, that is electron-rich species. The electrons from one of the bond, they shift to one of the carbon, and this bromonium cation, it attacks on that carbon, and it forms a non-aromatic carbocation intermediate, or arenium ion or sigma complex. This is a non-aromatic because this carbon, it is sp3 carbon. This unstable cation, that is intermediate formed by aromatic substitution, it has no longer an aromatic structure. It is unstable with 4 pi electrons, which delocalize over the 5 carbon nuclei. And this is the resonance hybrid of these structures. This is an unstable cation. Now the third step is the removal of proton formed from the carbocation intermediate. The intermediate formed due to the electrophilic aromatic substitution, this is the complex, the electrophile attack here, and this intermediate formed, it has high activation energy. This is unstable, and these electrons from this bond, they go to this positive charge, and hydrogen is replaced and it forms the HBr here. And again, FeBr3 is regenerated. This is a fast reaction, and here it is a slow reaction. And bromination of aromatic nucleus or bromination of benzene occurs. So this is the final product, bromobenzene, and this is an electrophilic aromatic substitution. If we take chlorine in place of benzene, then we have to take the anhydrous aluminium chloride, and here the chlorobenzene is formed by the same mechanism. And if we take excess of chlorine and the reaction condition is same, then all hydrogens are replaced and further substitution takes place on other carbons and hexachlorobenzene C6Cl6 is formed. So this is electrophilic substitution. Thank you very much. Please subscribe the channel. That is Globe Alchemy Chemistry. So thank you.